for Unit 4, Lesson 18. All right. So in this lesson, we're really talking about complex numbers and how we do different operations with complex numbers and with the letter I, which stands for imaginary. Okay. So initially, just in terms of math, we're taught that we can't take the square root of a negative number. And if you've done that in a calculator before or whatnot, you might have seen that term show up as a non-real answer. However, really, the square root of negative 1 is equal to I, which is an imaginary number. And there are different circumstances, as you can see here, where we do use imaginary numbers in real life circumstances. And if you move forward into much higher level mathematics, that you would definitely use them. That being said, we need to make sure we understand what a complex number is. So a complex number is a number that has a real and or imaginary part. So for instance here, 4 plus 3i, 4 is the part of this that's a real number and the I is imaginary. And the only other thing to note here is the way that this is written. So the standard form is a plus bi, which means the real part comes first. So in this case, you see the 4, that's written first, and then the imaginary part, the I, comes second. So that's kind of what you see here. So it'd be written like 4 plus I as opposed to I plus 4. Okay? All right, so then from there, there's really two different skills we're trying to have here with I and with complex numbers. So the first one is being able to simplify I to a power. So really, there are 4 ones that you just have to learn, and you should write these down, and you should learn them. So the first thing is anything to the 0 is 1. So just like we practiced from the last lesson, lesson 17, and we were practicing our exponent rules, x to the 0 was 1 because anything to the 0 is 1. So therefore I to the 0 is 1. So anything to the 0 power is 1. Okay, now from there you should also already understand this one, which is I to the first. Anything to the first power is itself. So I to the first power is I. And then from there, I to the second is negative 1, I to the third is negative I, and I to the fourth is 1. I can explain this to you further if you'd like, and you want me to prove out why these are true. Just let me know, send me a message, Canvas inbox, and we can schedule a time and I can prove these to you if you would like to know. That being said, you do need to learn these, and then from there, the pattern just continues. So notice how this pattern was I, and then negative 1, negative I, and then 1. Well, I to the fifth is I to the sixth is negative 1, I to the seventh is I to the eighth is 1. So it just continues to repeat, okay? So it's only important that we really know the first 4. Now let's show how we would actually simplify I to a power. So here you see I to the 11th. So if you had I to the 11th, what we want to do is rewrite these as groups of I to the 4th. However many I to the 4th groups we have, and then whatever our remainder is. So if we did I to the 11th, we could make 2 groups of 4, which is I to the 4th and I to the 4th. Well, 4 and 4 is 8, which leaves us the remainder of 3. So then we're going to rewrite these I to the 4ths as 1, because we just said here that I to the 4th has a value of 1, and then I to the 3rd has a value of negative I. And now we're just going to multiply these. Well, 1 times 1 is 1, and 1 times anything is just what it already was, so we just get negative I. Alright, so let's show it over here for I to the 9th. So again, we're going to say, hey, I to the 4th times I to the 4th. Well, that's like 4 and 4 is 8. Well, how much do we have left over? We'll just have I to the 1st. Okay, well, the value of I to the 4th is 1, the value of I to the 4th is 1, and the value of I to the 1st, well, anything to the 1st is just itself. Well, 1 times 1 is 1, times I is I. So I to the 9th would simplify into I. Alright, and then here's some practice problems for you to try, and you can always check these with the key that we have posted in Canvas for this lesson, for lesson 18. But you want to break it down with sets of I to the 4th, and then you're really looking for that remainder value. And even no matter what these exponents are, if it's just I to a power, it has to be one of these 4 answers. Okay, so that's what we do for I to a power. So what about when we're doing operations? So when we're adding and subtracting, actually, in order to add and subtract with the complex numbers, it's really actually pretty simple. You're just going to combine the like terms, okay? Notice here it says in italics, remember when subtracting, distribute the negative to all the terms in the second set of parentheses. But really, you would do that even if this wasn't an I. So the only thing that's different here is that we're just writing it in this format of a plus bi, which means the real part comes first and the imaginary part comes second. So notice here it's 5 plus 3i plus 2 plus 4i. So we're just going to add the real parts, which are the 5 and the 2, which give us 7. And then we're going to add the imaginary parts, which is 3i plus 4i. Well, 3i plus 4i is 7i. So we get 7 plus 7i. Okay, so then when we're doing it over here, you got 6, you bring that down. The 2i, you bring that down. And now we see the negative here. So we're going to distribute this in. So it's like negative times 2. We get negative 2. Negative times negative 3i. You're going to get positive 3i. And now we're going to do 6 minus 2, which is 4. And then we're going to combine the imaginary numbers. So 2i plus 3i. 2i plus 3i is 5i. 4 plus 5i. Okay, so that's really all you're doing here in terms of adding and subtracting with complex numbers. Again, we have a whole set of practice for you to try. Go ahead and try some of these, check them with the key, make sure you're getting them right. Just make sure you write in that a plus bi format, and otherwise it's the same as if we had a variable. Okay, so then the last part here with complex numbers is to learn how to multiply them. So really, we're going to multiply with the distributive property just like we would have if it was any other term. So let's start with that. So 4 times 3, 12. 4 times 5i is 20i. 2i times 3 is 6i. And then 2i times 5i is 10i squared. Okay, so from here, you would have done the exact same thing if this was an x instead of an I. Okay, here's the only difference. We now are going to substitute that I squared term with negative 1. Because didn't we say I to the second power had a value of negative 1? So now we're going to replace that I squared with negative 1. And well, now we're just going to multiply. Well, positive 10 times negative 1 is negative 10. And now we're going to do 12 minus 10. 12 minus 10 is 2. And now we're going to do 20i plus 6i, which is 26i, and we wrote it in a plus bi format. So there we go, 2 plus 26i. All right, let's show one more example question here. So I'm going to distribute 2 times 6, 12, 2 times positive I, which is plus 2i, negative 3i times 6, negative 18i, negative 3i times I, negative 3i squared. Okay, the next step is going to be, I see the I squared, so I'm going to replace that with a negative 1, so I get negative 3 times negative 1. Well, negative times a negative is a positive, so I get positive 3. 12 plus 3 is 15, and then we get 2i minus 18i. So 2i minus 18i, well, 2 minus 18 is negative 16i. And that would be my answer, 15 minus 16i. And if you feel like you need additional practice with this, there's again a whole bunch of practice problems in our notes. So make sure to take advantage of those and then check it with the key. Hope this helps.